In 8.2, we are going to take what you've learned in 8.1 and we're really going to step it up a notch. We're going to combine what you did in 1.4, add that to what we just did in 8.1, and then we're going to really see who knows what they're doing. It also deals with something that a lot of you are not very comfortable with, but some of you are getting better at, and that is rational exponents, or otherwise known as fractional exponents. What we're going to do in section 2 is that we're going to start dealing with things that are fractions inside the exponent. So the first thing that I'm going to do, I'm going to take my calculator and I'm going to input 2 to the 1/2 power. 2, delete, clear. 2 to the fraction 1/2 power. And on this calculator, when I do 2 to the 1/2 power, it's 1.414. 1.414. And now what I'm going to do is I'm going to press the square root of 2 and turn the square root of 2 into a decimal. And you'll see that it's 1.414. I show that to you so that you can see these two things are exactly the same thing as each other. When you're dealing with worksheet 2, you're going to need to know what 2 to the 1/2 power is, and as a decimal it's 1.4. I don't expect you to be able to do that without a calculator, but since we're not supposed to use a calculator this whole unit, I might as well just tell you in the chart on point D, I think it is, on problem number 1, you may want to put 1.4 in that box. Part D on the worksheet. And this should go right with our major part of the lesson, which is this. If you have a fraction in your exponent, the bottom part of the fraction is considered the root. That means that if I see a 2 there, it's the square root of whatever this is. If you see the top part of the fraction, it is the power. That would mean that that is the exponent part of your problem. So if I have k to the 3/2, I can change this 2 to the root and put a radical sign and then put the 3 either here or outside. It doesn't matter if it's inside or outside of the radical. Which means to go from exponential form into radical form, we're going to have to know which piece is which. If you look at what we did here earlier, I have 2 to the 1/2. This means that the 2 is the root, the square root of 2 to the first power with there's an invisible 1. It's the same thing. That's what we just learned. And the way I remember this is that flowers get their power from up above, whereas the roots of trees grow on bottom. And so it's kind of an easy way to know roots are on bottom and power is up above. You may not have ever seen a square root before, but they do exist in real life. If you would like to see a real square root, here is a picture of a real square root. Let me see if you can see that. See how the tree and then they have square roots. It's kind of in the shade, so you may not be able to see that too well. Let me see if I have another picture. This one, they came out somewhat rectangular, but those are some square roots. And they only grow that way because of the square patterns that are there, but you know how that goes. Anyhow, what you are going to end up doing, the majority of your problems are going to be how do you simplify. Numbers 8 through 19, I'm going to recommend dealing with the radical part first and then dealing with the exponent part second. So I'll show you how to do that. First question is number 5. Write the expression in exponential form. So this is in radical form. We now need to put it in exponential form. Since this is a square root, square roots are the only thing in math that have an invisible 2. How many of the 2x's do we have? We have one group. What's inside this radical? The radical goes over the 2 and the x. So if I'm going into exponential form, I'm going to put that whole thing, 2x, and I'm going to raise it to a power. The power is the 1. The root is the 2. That's it. That's how we do it. You could write your answer simply as 2x to the 1/2, or technically, if you combine this with rule 3 that we wrote down from last time, you could do this. I would accept this or this. They're the same thing. But that's not what the majority of your problems are going to look like. They're going to look like number 8 and number 13 and number 16. Let's look at these kind, because this is what you have to know how to do. Let's look at number 8. Let's do this one together, because you may get lost if you're not paying attention. The first thing you do is you convert it. This is the 4th root. I put the 4 right there inside that little v. The exponent is a 3. I usually will put the 3 outside of the radical just like that. And then I have a choice. You can either do 3 factors of 16 multiplied, or you can do the 4th root of 16 first. It doesn't matter which one you choose. I will always suggest to you, if you can do this part first, do this part first. So here's what you need to look at. You break this down. 2 times 8, 2 times 4, 2 times 2. You have to know what its factors are. 2 times 2 times 2 times 2 is 16, right? Like when you break it apart, you don't use the 16 anymore. When you break the 8 apart, you don't use it anymore. You don't use the 4 anymore. 2 times 2 times 2 times 2 is the same thing as 16. They're equal to each other. Do you have 4 factors to break out? Let's count. 1, 2, 3, 4 of them. Because we have 4, they can break out and simplify here. There is still this little 3 exponent that you have to deal with. So the 2 breaks out, but we still have to take it to the 3rd power. And as you know, because you don't have a calculator, you're not going to be allowed to use one on the quiz or the test. Let's do it by hand. 2 times 2 is 4, times 2 is 8. That's my final answer. The whole reason they do not let you use calculators is because your calculator, the Casios that we have, they can do this for you. If you really wanted to double check yourself, you could literally type in 16 to the 3/4 power, press equals, and then it would go 8. But we want you to be able to do it by hand. In this section, we're dealing with just numbers. In the next section, you might have some variables at the end of this worksheet. I think they throw variables in here, so we have to know how to do it. Let's look at 13. Now they threw in the same kind of problem, except there's a negative exponent. So we have to remember how to deal with negative exponents from section 1 with this type of math. How do we do it? First thing is we turn it to a positive exponent in the denominator. This is 1 over 64 to the positive 5/6 power. Now I'm going to convert it. One over the 6th root of 64 to the 5th. Root, power. Based off of what we talked about before. And now we have to go and do what we normally do. We could either do the 5 first, and do 64 times 64 times 60. Wait, that's going to be kind of big. Yes, I know. Let's not do it that way. Let's do the 6th root first. Let's break this down. 2 times 32. Once I break it down, we don't use it. 2 times 16. Once we break it down, we don't use it. 2 times 8. 2 times 4. 2 times 2. How many of those do I have? Let me see. Are there 6 of them? Do you have enough to break out? If you do, you circle all 6. It breaks out of this, but there's still that 5th exponent that you still have to do. So this is going to simplify to 1 over 2 to the 5th power, which means we have to know what 2 times 2 times 2 times 2 times 2 is, which we've already done. But just in case we need to know what it is, it's 16 times 2, or 1 over 32. But what happens if there's a negative inside parentheses and it's to the 1/3 power? What do? We do the same thing. We take the power. This is number 16, by the way. We take that power and we take that root and we go from exponential form and we put it into radical form, including that negative. Put that 3 there and the 1 there if we actually don't even need the 1 in this case. But we'll put it there just in case. Now, what's hard about a negative inside is that we have to think about factoring things that multiply to be a -8. And so there's only really one way to get there. It's probably either a -2 times a +4 or a -4 times a +2. I'm going to try a negative here. I'm going to pull a -2 times a +4. That times that is a -8. And then what you can do, since we're trying to get 3 of the same thing, is I can do a negative times a negative to equal a +4. It's the only way we're going to be able to get to 3 things that are the same. A negative times a negative times a negative is still a negative. It's a way to get 3 factors to pop out. And anything to the 1st power is itself. You have 1 factor of -2. It's a 1. It's like a Cheeto. You know never mind. I'm going to make you guys hungry before lunchtime. I'm not going to say it. So if that's the case, then we're going to do the same thing for number 17. Number 17 is a -27 to the 2/3 power. I'm going to put the whole thing inside a radical. I'm going to put the root is the bottom. Roots grow on trees on the bottom. And then the 2 is on the outside. We go from exponential form into radical form. And then what we're going to try to do is try to find 3 factors that multiply to be -27. And there's only one way to do it if you're trying to get to that negative. Let's do that real quick. Let's pull out a -3 times a +9 makes a -27. We always double check. And the only way to get 3 factors the same is I have to get a negative times a negative to equal the +9. Once you split it, you don't use it. If you have 3 of the factors, it pops out. But there's still that little 2 to deal with. So I have to take that -3, pop it out, and then I still have to square it, which a -3 times a -3 is a positive 9. That's my final answer. As you're doing some of these problems, always do it by hand. And then if you feel like checking your work with a calculator, you can. But do not use the calculator because you're not going to be allowed to use it on a quiz or a test. Don't get into that trap. 3 more examples. We're almost there. Number 20. Simplify. Leave answers in radical form. All variables represent positive numbers. So what I'm going to do now is I have this whole group to the 1/2 power. I'm going to put the whole group inside a square root. I can put the 1 there. I don't really need it there, but I'm going to put it there because that's where it belongs. Now square roots are nice because you only need a pair or 2 factors. And I know that's 5 times 5. I know this is x times x. I know it pops out here. 5 pops out and x pops out. Nothing's left inside. I have 5x to the first power, which means you have 1 factor of 5x, which is just 5x. It's as easy as it gets, I think. No, it's not as easy as it gets, but there you go. The last 2 examples that I have for you are 26 and 27. What they're going to do at the end of this worksheet is they are going to really see, do you know how to combine 8.2 and 8.1 together? It says simplify. When we simplify, we're going to have to use the rules that we have for this section and combine them with the rules we had for the previous section. So the first thing that I see, 3 to the 2/9. I'm going to leave that alone. Equals 3 to the 2/9. This can be written in exponential form. I'm going to change that to 3 to the 2/3 power. That way it's now in exponential form. Since I learned all my rules in 8.1 in exponential form, now let's go ahead and see if we remember the rule that we just learned. It's your first rule, rule number 1 in your 8.1 notes. If you have 2 bases that are the same and they're multiplying, what do we do with the exponents? Absolutely, we add them. So I'm just going to write out, this is 3 to the 2/9 power plus 2/3. Now because you're adding fractions and you don't have a calculator, you need to find a common denominator. How do I find it? I have to multiply this one by 3 over 3. Hopefully you remember doing that. This is the same thing. I'm going to leave the 2 over 9 alone. This is 2 times 3 is 6/9. 2/9 plus 6/9 is equal to 8/9. Simplify. Leave your answer in simplified radical form. Is this radical form? No. 9th root of 3 to the 8th power. That's where I would leave it if I were you. That one's a little complicated, and the hardest that it gets are these kind of questions where you have to go, okay, I'm adding exponents. Oh yeah, for fractions I also have to have a common denominator when I'm adding them. Okay? Last one, number 27. Number 27, we have x to the 1/4, and we're taking the 5th root of it. What I think of when I see this is I think of something is to the 5th root power you can say that this is the exponent and that this is the root. So the way that Mr. Dittman shows this is he does exponent over root. 1/4 divided by 5. But I think that looks a little bit confusing. I think that some of you might look at that and go, well, how do I do 1/4 divided by 5? It's 1/4 times by its reciprocal. It's the same thing. So what I do is I do it slightly different than this. This is Mr. Dittman's answer, which is going to be the same answer as ours. X to the 5/4 power. I go like this. I say you have x to the 1/4. The 5 is here. I have one group of this stuff there. This is the same thing as x to the 1/4 to the 1/5 power. Did I mess up here? No, I did, didn't I? Okay, I'm sorry. Because our answers need to match, and I just realized that Mr. Dittman, I messed up your explanation. Divided by 5 is the same thing as times by 1/5, which is the answer of 1/20. Sorry. That would multiply. X is equal to 1/20. They're the same answer. Whichever way you like better, you can use. I will primarily use this first method. I'm going to stop your notes right there.